Part A, here we go, y'all. Part A says, does f of 1 exist? Yeah, okay. What is the value of f of 1?
1.
It's right here, right? That's an algebra value, so it is 1. Okay. Does the limit as x approaches 1 exist? Yes. What is the limit? It's 2. So the limit at x approaches 1 of your function is 2. Does your limit equal to your algebra value? No. Based on that, is this a discontinuity? Yes, right? Is f continuous at 1? The answer is no. It is not continuous because what kind of discontinuity is this? A hole, okay? So no, because f of x has a hole. Guys, a hole is the only type that is a removable, okay? See, that's easy. Not a big deal. Reducible. 3. For the given piece y below, can you please graph it first? Now you have to graph it on your own. It is great.
What's the other one better?
I'll hand back your quiz after our lecture today. Did you guys have something like this?
Yeah.
So verify, make sure we are on the same page. On the right side, if I pick 4, 4 divided by 2 should be 2. So, okay. I can pick 6 as well. If I pick 6, 6 divided by 2 should be 3. So this question is really asking, which of the discontinuities are removable, not removable, and give you reasoning. Do we even have a discontinuity? Yeah? Okay. Is it a removable kind or non-removable kind? Removable. So discontinuity. Oh, let's, since you guys already know it's removable. Removable discontinuity at where? At x equal to 2. Okay. Now it says, give me the reason to prove that it's a removable. What's the reason? Algebra value. What's your algebra value? 2. Okay. Is the same or not the same? Not the same as your limit, okay, your calculus value, limit as x approaches 2 of your function. What's the limit? 1. Okay, so obviously 2 is not the same as 1. So that's how we know that it's a whole. So we have some properties for our continuous function. But 5 of them to be exact. So if I give you guys, okay, if f of x and g of x are continuous at a point, let's call it x equals to c, then if we have two functions, okay, they both are continuous at the same value c. And they don't have to be just one value. Technically, I can have an interval of continuous, right? So if those two functions are continuous, when I add them, So if I take f of x and add g of x, the answer, a new function, the answer should still be continuous at c. Okay. Do you guys see how that's about? Okay. What if I give you example? F of x is x minus 2. By the way, what's the domain of that? All real numbers, right? Is that continuous everywhere? Yeah, so technically your c value is all real number. How about another one? G of x is x squared plus 2. So creative. What happened when I add those two functions? What would you get? Yeah, if I do f plus g, which is the same thing as g of x, I get x squared plus x. Because f is continuous everywhere and g is continuous everywhere, when I add the functions, my answer function should be continuous everywhere. If f is only continuous at a particular location, and g must be continuous at that same location, when I add them, they should be continuous at the same exact location. So that's what it means. You can also subtract, okay? So difference, when we subtract f minus g or g minus f, it's continuous also at x equals 2 c. Over to 3 more properties. We can also multiply them. Okay. So the product of f times g is continuous at x equals to c. When I multiply f and g from the made-up equation, would you agree I just get a bigger polynomial? Yeah, and a polynomial is still continuous. Quotient is when I divide. Now, when I divide them, okay, obviously f divided by g, given that g of x could never ever be 0. Okay, I have to state that first, otherwise it's not going to be the same. When I divide them, this should still be continuous at the same domain. And last one is when we multiply by a constant. So constant. We can take k and multiply by f of x, or we can take k and multiply by g of x. It doesn't matter what constant you have chosen. Should still be continuous at x equal to 2c. Okay, so that's all about continuous functions. Now, one more with composition. What? Oh, yeah, you guys know what this means? Yeah, like, yeah. That means we don't feel like writing that over. Had anybody seen that? Okay, I just want to make sure. Okay. Okay, composition. Anybody remember what a composition of function was back in Algebra 2? Little bubble, right? Yeah, exactly. That's what it is. Okay. If f is continuous, the language for this one is slightly different. Okay. If f is continuous at x equals to c, and g is continuous at x equals to f of c. Okay, so see that language right here is slightly different. Then f bubble f. That's a composition notation. Do you guys remember that back in the day? Okay. By definition, do you guys also remember that could be rewritten in that way? Okay. So this is what it's saying for that first sentence. When we do a composition, so first is if my f function is continuous at some x value, it could be a one value or it can be an interval values. Then it says g has to be continuous at this value. What is this? Why is this written this way? X equals f of c. Why is this written this way? Because look at the composition. Isn't g now has an input value? All of the g inputs come from where? From the output of f, exactly. So that's why it's written this way, right? Because g, because of the composition, g's inputs will be all of the outputs of your f. Okay, so that's why the language is written that way. Okay. So then f composed with g composed with f, which is g of f of c, is continuous at x equals to c. In another word, so meaning, if we take the limit as x approaches c of g of f of c, it should equal to the composition of g of f of c. So that's what it means. Any questions on that? Does that make sense for that definition? You sure? Okay. Okay. Example 4. Give a formula for the extended function for our given f of x equal to x to the third minus 1 divided by x squared minus 1 that is continuous at x equals to 1. Currently, is this given function continuous at 1? No, because when I plug in 1, it's 0 divided by 0, right? That's totally not okay. So I would like for, this is the language. It wants you to give a new equation or new function, okay, that will produce similar graph that will be giving us a continuous value at x equals to 1. So all we have to do here is, who remembers how to factor? Yeah, exactly. We should all. How do we factor out the difference of two cubes? Okay, so a cubed minus b cubed. What was the formula? A minus b times the quantity. A squared, good, plus. All right, go ahead and factor out the numerator and denominator. All right, Alex P., do you have the factors for the top? All right, what are the two factors for the numerator?
So it's x minus 4. X minus 1.
Mm-hmm.
And times x squared plus x.
Good. Right. Kit, do you have the factors for the bottom? Good. So from here, can you guys see that I can reduce? Yeah. So my new reduce equation, check it out. Is it now continuous at 1? Yes. I'm good. Box it up. By the way, because I reduced that, it didn't ask for it. Because I reduced that, what kind of discontinuity do we have? At where? Yeah. This new function, okay, when I plug in 1, would you agree on the top I have 3 divided by 2, right? So it's okay to have that, okay, because I want to plug it in my reduced formula, I have that. But technically there is a whole at x equals to 1. 1 comma what? Anybody know? Someone said 1 comma, a whole at 1 comma. We have to discover this in a little bit. Do you guys remember how we find the whole back in the days when you guys graph these out? Obviously not. It's okay. We'll come back at it. Is it 3 over 2 is the question. 1 comma 3 over 2. Do you guys agree? Eons ago, just last year. Yeah, we just have to put in, we just have to enter in our 1 and then get the y value. And that's all that is. And so, yep. Okay. Last example. You guys saw this already? You guys saw this already from homework 6 or a similar one, not identical. You were asked to graph out one function or sketch out one function that fits the given criteria. Okay. So your one function has to have f of -2 must exist. So what does that even mean? F of -2 must exist.
Value of x.
It's not a whole, you're right. A value, an algebra value. So because it doesn't tell you what it is, what do you want it to be at -2? What do you want it to be at -2? 1. You know, so weird that all 3 classes pick 1. And I just kind of let it go, and everybody in all 3 classes pick 1. That's like the most bizarre thing all day today. Okay. All right. Next, the limit. Okay, the limit as x approaches 2 from -2, from the right is exactly the same as your f of -2. What is that going to look like? So I'm going to come from here, right? The right comes from here. Keep on going. It has to have the same height as that dot. So technically, you can make it any way you want as long as it's a function. So what do you want to make it like? Wavy, straight? Oh, okay. Okay, there's yours. You can make it however you want. Okay, you can make it pretty. You can make it down. You can make it up. Okay, just... Okay. As long as when I do the vertical line test, it has to pass. Okay? Guys, don't do this. Because that does not pass your vertical line test. So, all right. Well, Thomas did this. Thomas, that's not going to pass. Okay. All right. Next, the limit doesn't exist at -2. So coming from this side, should I have the same height as the other side? No. So what do you want this side? Straight?
2.
Yeah, it doesn't matter. Pick something. 3. Sounds good. Okay. And that is an egg roll.